Definite integrals. A definite integral is an integral with limits. For example, the integral of 2x dx from 3 to 1. The lower number, 1, is called the lower limit, while the upper number, 3, is called the upper limit. We study definite integrals because they will be used in applications to be seen in later sections. To evaluate the definite integral, the integral of 2x dx between 3 and 1, step 1, integrate 2x as usual, leaving out the constant plus c of integration. So the integral of 2x dx is x squared. Step 2, now evaluate the function x squared at x equals 3, the upper limit, and subtract the value of the function at the lower limit x equals 1, which we write as x squared between 3 and 1. So we have 3 squared minus 1 squared, which is the upper limit minus the lower limit, which is 9 minus 1, which is 8. Notice that the outcome of a definite integral is a value or number and not a function. In general, we have the following definition of a definite integral. Definite integral. If the integral of f of x dx is equal to f of x plus c is an indefinite integral, then the integral between the limits b and a of f of x dx is equal to f of x between b and a, f of b minus f of a. So we subtract the upper limit minus the lower limit. Evaluate the integral of 1 minus root x squared dx between the limits 1 and 0. So the first thing we're going to do is multiply out these brackets. So 1 minus root x squared gives us 1 minus 2 root x plus x. And minus 2 root x can be rewritten as minus 2 x to the power of a half. So now we can integrate. So we'll come back to the limits in a minute. So to integrate 1, well, 1 is really x to the power 0 plus 1 over 0 plus 1, which is x to the power 1 over 1, which is x. So to integrate 1, we always just get x. Now to integrate minus 2x to the power of a half, well, we leave the constant minus 2 outside the brackets, and we integrate x to the power of a half. So x to the power of half plus 1 over half plus 1 is x to the power of 3 over 2 divided by 3 over 2. So we change divide to multiply and invert or turn the second fraction upside down. So we still have the minus 2. We're multiplying now by 2 over 3, so we stick the 2 over 3 in front, and it's x to the power of 3 over 2. And then to integrate x, well, this is x to the power 1 plus 1 over 1 plus 1, which is x squared over 2, which is a half x squared. So now we've integrated, now we just have to evaluate the limits. So x we bring over, minus 2 times 2/3, x to the power 3 over 2 is minus 4 over 3, x to the power 3 over 2, and we bring over the half x squared. So now we're going to write out what's inside the brackets and swap each x value for our upper limit, which is 1. So x just becomes 1, minus 4 over 3x to the power 3 over 2 becomes minus 4 over 3 times 1 to the power 3 over 2, and a half x squared becomes a half times 1 squared. Then we have our minus, and then we do the same, we write out what's inside the brackets, but this time we swap each x value for 0. So we have 0 minus 4 over 3 times 0 to the power 3 over 2 plus a half times 0 squared. So what's inside the first set of brackets gives us 1 minus 4 over 3 plus a half. Then we bring down the minus, and what's inside the second set of brackets is just 0. And simplifying, we end up with 1 over 6.